Hello, and welcome to Algeomulus Prep Academy, the channel for your algebra, geometry, and calculus needs. The lesson for today is Rolle's Theorem!
Rolle's theorem is a theorem which states that if f is continuous on the closed interval a to b and is differentiable on the open interval a to b, and if f of a equals f of b, then there is at least one number c in the open interval a to b. Such that f prime of c equals 0. So basically, if you draw a line from f of a to f of b on a continuous and differentiable function, and the slope of that line is 0, then there's at least one tangent line on that interval with the slope of 0.
For our first example, the problem is f of x equals x squared minus 5x plus 4, bounded from 1 to 4. When you graph the function, you notice right away that it is a parabola. Because the function is a parabola, it is continuous and differentiable for all real values, including our specific interval from 1 to 4. Also, f of 1 equals f of 4. Therefore, Rolle's theorem applies. There is at least one number c in 1 to 4 such that f derivative of c equals 0. Since f prime of c equals 0, just set the derivative equal to 0 and solve for c. c is equal to 2.5.
The next problem is f of x equals 1 minus absolute value x minus 1 from 0 to 2. Next, graph the function. After you graph the function, you should see if the function is continuous and differentiable. Our problem, it shows that the function is continuous at a and b, where a equals 0 and b equals 2, but there is a cusp at x equals 1. So does Rolle's theorem apply? No, because Rolle's theorem states that f has to be continuous. F of a must equal f of b, f must be differentiable for all x and b, and the slope of f prime of x has to equal 0. The cusp in the function is not differentiable, so f of x is not differentiable for all x, a, b. Therefore, Rolle's theorem does not apply.
Our last problem is f of x equals sine of 2x from 0 to pi over 2. Since this is a sine function, f of x is continuous and differentiable for all real values of x, including the interval 0 to pi over 2. Also, f of a equals f of 0 equals 0, and f of b equals f of pi over 2 equals 0. This satisfies the part of the theorem that requires f of a to equal f of b, and in this case, f of a is equal to f of b, which is equal to 0. So, since f of x is continuous on the open interval 0 to pi over 2, and since f of x is differentiable on the open interval 0 to pi over 2, and since f of a equals f of b, then there is at least one number c in 0 to pi over 2 such that f prime of c equals 0. That c value is pi over 4.
So basically, for Rolle's theorem to apply, the function f must be continuous on the closed interval a to b, and must be differentiable on the open interval a to b, and f of a must equal f of b. So if it's continuous, differentiable, and f of a equals f of b, then there's at least one number c in a to b such that f prime of c equals 0, and there is a flat tangent line at the point c comma f of c. And that's Rolle's theorem.
Class dismissed. Thanks for watching our video. Like our video and subscribe to our channel, Algeomulus Prep Academy.